Welcome back to Your Desk University. This series we've put together because architects are changing how they work. They're connecting with the internet, with external data sources and functions that exist outside of their walls. And we know that you want to be doing the same thing, and we want to be learning and growing in this together. So this series is here to help you upskill and help you see how you connect your work with your web. Stay tuned. I actually forgot to tell our speaker today, but I'm going to ask him for one 30-second tip before he even gets going. I want to first say thank you to the other people that participate in pulling this off with me. With that, I'll bring Andrew Human on, who's now on the screen, and he is a man of art and algorithms. He's a man of geometry. If you have seen his streams on YouTube about doing art computationally, they're really fascinating, and you can actually get his signed work. Yeah. He's a generous educator and the creator of Human UI. But when I told him I was going to introduce it that way, he said, you know, Human UI is so 2018. And that's exactly the way that he thinks. He thinks beyond the now. He thinks about how things can be built to create a larger thing, to create larger things by others. So I want to use Human UI as an example because many of us know about it. And many of us know how it wasn't built for one thing. It was built as a framework to allow for a larger space. Now he's at Hypar. He's been there for a few years and he's helping build the framework there. And I am really grateful that he agreed. Thank you. Which way are you? There you are. Thank you, Andrew, for coming on board and talking to us behind the scenes of Hypar. What does it take to build? What is the 3D viewer? How does it work? How do they decide on new decisions? What are parts of their schema? Do they use Amazon or Azure? And why? This is your chance to ask these kinds of questions. He'll have some of them prepared to help share. But definitely, I see some of you in the chat, so thank you. But go ahead and let us know what you're interested in. Are you interested in learning about Figma or Adobe XD? If they even use it. Yeah, I'm just throwing things out there. Yeah. So for computational designers that are just starting to dabble with the web, this will be really helpful as you're thinking about a potential project you're working on and seeing what a pretty established framework like Hypar has decided. So with that, Andrew, thanks for being on and welcome.
Awesome. Thank you so much. It's great to be here. I was really excited when Timon invited me because I feel like most of the time I'm invited to talk, I have to give sort of a Hypar sales pitch. And there will be a little bit of that in here, but more than anything, I'm really excited to geek out a little bit about, some of the technical underpinnings of what we've been doing, the kind of like nitty gritty of how Hypar works from a technical standpoint. And, maybe that will inspire you to build your next web application using Hypar, and maybe it'll just have lessons for you if you want to go build something yourself with some of these parts. So really excited to share with you today.
Yeah. Thanks so much. Yeah, let's jump. 30-second tip. Did you come up with one? Because I didn't warn you. I was going to ask you that.
I think my 30-second tip is install GitHub Copilot. Nothing has changed my life and work as a coder like having AI in my coding environment. It is absolutely transformative, and we're just at the very beginning of the possibilities that stuff unlocks.
That's a good one. I've actually heard that another time just this week. So
yeah, it's truly magic. Cool. Well, let's jump right in. As I said, I don't want to do this as a Hypar sales pitch. I will start by introducing Hypar a little bit, just so you know what it is we're talking about when we're talking about the sort of technology behind Hypar. But that's really what I want to focus on, is kind of like the libraries, the frameworks, the systems and infrastructure that make Hypar possible. So first, just to kind of give an overview of what Hypar is and how it works. Not everyone is familiar with it. Hypar is a web-based design environment. So you can think of it as sort of like a next generation Revit operating in the cloud. But it operates around the idea of a function. So a function is like a little encapsulated piece of logic represented in code that is responsible for a single building system. And HypeR is an ecosystem of these functions. Some of them are written by the HypeR team, some of them are written by our users. And in HypeR's 3D environment, you use these to basically start designing your project. So you might pull down a function to establish your project site and pull down another one to set up the 3D building context and the location. You might pull down another one to do a kind of quick schematic massing study using a particular strategy for the building envelope. And then you may decide that you don't actually like that strategy. One of the cool things about HypeR as a platform is that you can kind of mix and match and pull down different strategies for the same kinds of systems. So I can throw this one out and bring in a different envelope strategy and maybe say, I don't like that one, and pull in another one that's slightly different. And all of these systems talk to each other. So if I pull in floors, the floors is always adapting to the envelope strategy that I've pulled in, and the structure is adapting to where the floors are, and so on and so forth. So that's kind of the theory behind HypeR. What does it look like in practice? So this design environment, it's actually already looks a little bit different from this. We've been doing a lot of work around the UI, but effectively it is this 3D web environment where the tools that you manipulate are entire building systems. So instead of drawing a single wall, you add a wall system to your project. Instead of drawing a single curtain panel, you add a curtain wall system to the entire project. And these systems can be, physical things, or they can be analytical. So you can drop in, a view analysis system or a solar analysis system or a financial analysis. We have customers building their pro formas and integrating them into HypeR. And as I already said, one of the most important things about this, and one of the things which has really driven a lot of the technical decisions we've made, is this vision that anybody should be able to contribute new systems to the HypeR ecosystem by writing functions. So we have customers like Focal Point Lights, who built as a HypeR function this product configurator for one of their products, which is the Mora ceiling system, which combines integrated lighting and these sculptural acoustic baffles. So they took the logic of their product, made it into an interactive configurator on HypeR, and they can embed this in their website. They can share this link with somebody and have them sort of configure the product. And it always sort of automatically instantiates the logic of that product system. And we have, for fully fledged design environments, you might have a lot of functions involved. So this is a video of building sort of an interior test fit using HypeR. So we've got a single floor we've pulled in, we've got a core, we're defining some circulation, we're taking the space around the circulation and kind of splitting it up into pieces. We're assigning programs to various pieces of this, and then HypeR is great for various kinds of automation. And in this example, it's automatically laying out the furniture in each one of these spaces. So this is kind of a full integrated test fit design environment in this particular case. And as we make changes, the furniture layouts adapt and the walls regenerate and the interior partitions are all updating. And the cool thing is, I can add that Mora ceiling system we just saw in the previous slide to this same model. So it can operate as a standalone configurator, or it can be a part of a more involved model. So it's like being able to pull in not just family content from, a building product provider, but actually the logic of an entire building system. So we're doing things like automating sprinklers and pipe routing and various HVAC systems, and you can just drag and drop these systems into your model, and they integrate with everything that's already there. So that's a super fast overview of kind of like what HypeR is. I'd love to take questions about that a little bit later, but I want to kind of structure this talk around a kind of high-level understanding of the architecture of HypeR as a system. So what are the pieces and parts that come together to make HypeR work the way that it does? So we just saw the front end, hyper.io. You access that interface by going into your browser, typing hyper.io. And when you do that, you are communicating with our API. And this API is kind of like the gateway to all of the other services and databases and things that make up Hypar's infrastructure, like our workflows. So we have a database of all of the workflows. And when we say workflow, what we really mean is sort of like a Hypar file or a Hypar project. When I start a new test fit or a new multifamily residential project, I'm creating a new workflow. And each one of those workflows contains the functions that I've added to it. And that together makes up the entire project. So the API handles communication to that collection of workflows and also handles, kind of keeping track of and interfacing with the functions, which are really the heart and soul of Hypar. These are the things that run code and do the work and generate the building systems that you're actually putting into your model. There's one other system here, which is pretty important if you are actually contributing new functions to Hypar yourself. So if you're a software developer and you want to write a new system on Hypar, you will build a function and you'll utilize the Hypar CLI to do that. The Hypar CLI is a tool you can install and download on your system, and it streamlines the process of creating new Hypar functions. It writes a bunch of code for you, handles uploading that into Hypar's infrastructure so that it can be executed in the cloud. So this diagram is obviously a big oversimplification, but I think it's useful as kind of like a map of the big critical parts as a way to contextualize some of the specific systems that we'll be talking about.
Yeah, that's really cool. I actually want to jump in here. I imagine
Please.
You're probably going to get more into the CLI and talk about it. But I think as you talk about the infrastructure and I actually am, even though we're talking mostly about the web, I think a CLI specifically is really interesting because you see it with Google's Firebase. You see it with other, obviously with everything JavaScript. There's a lot of things that are in a CLI, anybody who's using Git. So being able to kind of like run a bunch of commands directly as you're working or kind of aggregated commands, because I imagine the CLI is, like you said, it's kind of wrapping a bunch of things. Do you want to talk a moment or two about some of those functions, or is that kind of come up and we can just kind of keep rolling?
Yeah, we'll get back to that, I think. But I think you're absolutely right about the CLI thing. I think this is a pattern that we've seen emerge from, Amazon Web Services has a CLI, VueJS has a CLI, React has a CLI. It's a very common, very friendly developer-facing pattern to basically issue a little piece of desktop software that is your scaffolding, is the thing that gets you up and running without having to, start from an empty folder. So we've tried to follow best practices we've seen elsewhere in the industry, and the Hypar CLI is an example of that.
Yeah, cool, thanks.
So this upper right-hand corner here between the API and workflows and functions, all of this lives in the AWS, Amazon Web Services universe. So if you haven't heard of this, AWS is basically the backbone of the modern internet. It is the world's largest cloud service provider, and they have the craziest list of services and products that you can use to compose your web application. And this is, there are a couple of these big cloud service providers. There's Amazon, Google Cloud Platform is another one, and Azure, Microsoft Azure are kind of like, those are probably the biggest three, and there are other sort of smaller players. But we've gone with Amazon from the beginning, and that decision predates me, so I can't tell you why we selected Amazon over other things. But I think a big part of it is because we want to be an ecosystem where anyone can contribute their logic onto the Hypar platform. Amazon has a really great product offering called Amazon Lambda, which is basically a service for authoring microservices. So what do I mean by that? Amazon Lambda basically allows you to take any little piece of code. I write some method or some function, and I want it to take in some input, and I want to give me back some output. Amazon Lambda is designed to allow you to just write that code and then deploy it onto the cloud and not have to worry at all about what server does it run on. How many servers do I need? What happens if two people try to call this method at the same time? Amazon's infrastructure around Lambda automatically handles all of the provisioning and scaling, so you don't have to manage these servers. All you're responsible for is the code that actually runs, what goes in and what comes out. And it's also a really affordable solution for compute because you're really only charged for the time that the system is being used. And it was a natural fit for HypeR because the same way that Amazon allows anyone to write a little piece of code and kind of connect to it and wire it together into a more complex system, that's very much in parallel with our vision for HypeR itself, where you can take a little piece of building logic and wire it together into a dynamic system with lots of these kind of functions or building systems all talking to each other. So, we talked a little bit about the CLI. Basically, all the CLI is doing for us is making it that much easier for you as a coder to write a little piece of code write a little piece of code that does some 3D BIM logic and deploy it to an Amazon Lambda so that it can participate in our infrastructure. But Amazon also has their own CLI, which you can use to spin up Lambdas, in a sort of less pre-cooked way. So that's kind of a very, very brief tour of the backend where the functions on HypeR are running their code and how you, kind of contribute those functions. But let's go back to the front end for a minute. When you go to HypeR, when you log into hyper.io, what are you actually interacting with? What systems form the basis for this user interface? So there are several really important ones. It's a long list, but I wanted to highlight just the really important ones. One is VueJS, which is our front-end framework. So there are a lot of different front-end frameworks out there. It seems like a new one comes out, every week, and people are very opinionated about what frameworks they use. I really love VueJS. I've been using it since I was at WeWork. It's really just like super powerful, super easy to use. It's sort of gradual. You can learn a little bit and do a lot of useful things, and then you just learn more and more over time.
I think I might just have to cut this off now because I've become a React guy, and so
oh no.
two frameworks collide. But no, I think you're exactly right. It's like
they're both great.
You find your space in one of these frameworks, and you learn to love it.
Totally. And the thing is that these frameworks, as they're growing and evolving, are learning from each other too. A lot of the best ideas from Vue are making their way into newer platforms. A lot of the a lot of the hooks concept from React is sort of finding its way into Vue 3. So there's a lot of synergy, and a lot of these frameworks are really ultimately just different flavors of the same thing. They obviously have their advantages and disadvantages. But
as a decent Vue user who've used it for a little bit, what is like one thing you like about Vue that you think its flavor really resonates with you?
I mean, it's the whole ecosystem more than any one specific thing. I find now that I really understand it, I find its reactivity model really intuitive, where I think React sometimes can tend towards like over computing, over rendering. I think Vue makes it easy to be very selective about that. But I will say the one thing that makes me really jealous of the React ecosystem is its integration with 3JS. Have you played it all with React 3 Fiber?
React 3 Fiber and React 3 Dre. I've been
oh my God,
spending a lot of time in there. Yeah.
Super, super cool. So for those who don't know, first, to back up a little bit, 3JS is the library which is the basis for our 3D viewer. I think most 3D you ever see on the web utilizes 3JS. There are others out there, but 3JS is by far the dominant one. And the thing we were just talking about, React 3 Fiber, is a really interesting development which allows you to basically write 3JS code using React syntax. So it is effectively a kind of like a renderer. I forget the term that they use for it, but it allows you to basically write sort of nested tags the same way you would write HTML, but have that actually create interactive 3D experiences using 3JS. And it's really, really sophisticated and a very intelligent model. And I wish there was something like it for Vue.
Yeah, I'm going to jump in here for a moment because I know a lot of our viewers are not language programmers, right? A lot of you are Dynamo users, you're Grasshopper users, and you're just like thinking about connecting to the web. Others on here are, solid, web developers and interested in like learning that. So we do draw from that audience, and that's why we exist. We exist because people have like figured out some graphical programming or maybe some language programming and wanting more. And I just want to like pause and say like what he's talking about with regards to Three.js, or really what Hypar in a sense does, is abstracts a lot of the code that it takes to do a certain thing into a thing that you're familiar with. I'm using thing very generically, but just the way that Dynamo or Grasshopper has nodes or components that hide the function, the language function behind it. These kind of do the same thing with abstracting a more complex, more, I'm going to say convoluted for lack of a better term, piece into something that you as a developer might understand in one of the spaces. But I think that analogy is true. I mean, that idea of abstraction is very, it's actually very familiar with graphical programmers, even if they don't know the term. I would, that concept, and you're obviously aware of this as well.
Yeah, I mean, I talk about abstraction a lot in a lot of the presentations I give, because it's actually really, as you've identified, it is a core concept for Hypar. I think ultimately, if you look at the trajectory of software for design, really software for anything, but if we just talk about design, you start with, hand drafting, and then you go to CAD. CAD is an abstraction layer over the drafting board. It is a way of basically encapsulating like the logic of drawing straight lines. Fast forward, you get to BIM. BIM is an abstraction layer over CAD. It is a way for producing 2D drawings by working at a higher level of abstraction where you're working with 3D models. And what we're trying to do, and what I think, in various ways, things like Hypar, things like Grasshopper earlier, things like, the configurator tools like TestFit and others are all trying to come up with the next level of abstraction over the top of BIM, where you're interacting with building systems, and the thing that comes out the other side is a BIM model. So, the history of every kind of software is this march up a ladder of abstraction. I think that's also the history of programming languages. I mean, new lower level ones emerge all the time, but I think, we achieve a radical leap in accessibility every time these tools for expressing ourselves jump up a level of abstraction. So when we went from RhinoScript to Grasshopper, it opened the world to a bunch of people who were finally
who didn't want to write
like,
ones and zeros or letters and periods or for whatever it is. Yeah.
So, I think it is really important, and it's what we're trying to do. And I think it's a really useful mental concept for kind of understanding where things are going to go. This sort of like relentless march up the ladder of abstraction is sort of a constant, I think. So to just, I don't have a ton to say about Three.js specifically, other than it's awesome and super powerful. It has a really amazing community. And I think the best way to learn Three.js is to go dig through their code examples. There's a really, really great public sort of examples page where you can interact with all of these models and then just immediately go look at the code and see how they're built. And half the features that I've built for Hypar's web UI are like things that I went to the examples page and was like, hey, how did they do this thing? How did they do raycasting? How did they do selection? How did they do selective visibility of objects? Whatever it is. And so I'm constantly borrowing from these public examples in order to kind of fold them into the set of capabilities that I want in our app. So another sort of front-end topic. This one I think is pretty exciting to me because this is a fairly recent development. So in this model that we were looking at, we've got sort of a single user who is actively communicating with the API. They're editing their workflow. The API is saving their changes to that workflow. But over the last year or so, we've added real-time multi-user collaboration. And so that means that two or more users can be interacting with the same workflow at the same time, potentially even making edits. So let me actually give you a real quick demo and show you this in action, because I think it's pretty cool. So we've got, oh, I got signed out. 1 second.
No worries. As long as he doesn't make me open up another screen to manage multi-user mode. If you were all here with me, you would understand.
Yeah, we've got a too many screens problem.
We have a too many screens problem.
So this is the new feature in Hypar. I am in this workflow and I have shared it with another user and I've given them edit access to this workflow. And you'll see that if I'm over here, I can see the other me, a little avatar up here in the top. And if I select an object over here and I'm in like a 3D view, I can see what object the other user has selected. So if I select this guy, it'll highlight over here. And if I make changes to this workflow, like I want to take this stair and move it, let's, take this stair and shift it down or something. Then those changes propagate instantaneously across all users, so that, like a Google Doc, everybody's looking at the same thing. So this is very different from a model like Revit has, where you're kind of explicitly syncing to central at a specific moment. Instead, this is just like we're all working in the same thing. It's more like Figma or a Google Doc, where you're kind of collaboratively working on different parts of the model. And I think as a user-facing feature, this is really powerful. Our users have been really excited about this, but it's also really interesting from a technical standpoint. But I'll pause for a sec before I dive into the technical details.
I imagine the technical part's really interesting.
Yeah, so this seemed like, I don't know, maybe it seems like a hard problem to you, or maybe it seems like an easy problem. I assure you it's a pretty complicated problem to make this work reliably. Because, let's imagine we're two users working on this project, and we both make changes at the same time. There has to be some sort of central source of truth, represented here by big blue dot, who can turn around and say, okay, I'm going to combine these two changes and send you both back a thing which reflects both of those changes. So I think a classic model of this is that you have sort of a single bottleneck server whose job it is to coordinate all of these changes and send them back. But things get tricky when maybe we say conflicting information. If I say the podium should be retail and you say the podium should be parking, and we both hit save on our change at the same time, what should happen? So it turns out that the most important thing is not that one user gets picked over another, but that the most important thing is that both users end up with the same answer. So the disaster would be if you kept working with your parking podium and I kept working with my retail podium, and we were living in separate universes, even though we thought we were occupying the same model in the same way. That would be a problem. So, in recent years, we've seen an explosion of tools that have this kind of multiplayer simultaneous editing mode. We mentioned Google Docs, Figma is another one. And then I think a lot of folks are trying to build, Figma for BIM or whatever that looks like. But effectively, in a distributed system, you may not actually have a single central source of truth. There may be many players communicating back and forth, and they all always need to see the same thing. They need to be looking at the same reality. And so over the last 10 years or so, a technology has emerged to do this in a really reliable way. And it is called CRDTs, which stands for conflict-free replicated data types, which is quite a mouthful. And I don't know why there's no F in the abbreviation. Maybe CFRDTs was just too much.
When you abbreviate something and it has 6 characters, did you really abbreviate it?
Yeah, exactly.
I haven't heard of these before, so I'm curious.
This is the technology that Figma uses. So there are basically 2 models for this kind of real-time collaborative software. One is called OT, or Operational Transform, and this is what Google Docs uses, or at least, yeah, and CRDTs are what Figma uses. And I don't know much about operational transforms. I'll post a link. I actually have a link on a later slide that does a better job of explaining how these things work and what the differences are between them. But the most important thing to know as a user is that you don't actually have to implement this complicated system. There are existing libraries you can rely on that let you do this.
Back to the idea of abstraction.
Right, exactly. So the most important things to know are that CRDTs are fundamentally a data structure for distributed systems. They are designed for multiple people looking at the same information and needing to see the same thing. So these multiple devices and clients can update data at the same time. That data is guaranteed to be eventually consistent. That's actually a technical term, which just means that eventually, after some arbitrary amount of time has passed, everyone will be looking at the same truth. And like I said, these are the basis for a lot of modern multi-user editing tools like Figma. So a big shout out to VueJS, which is the JavaScript library that we use for this. They make it very easy to utilize CRDTs. So we use VueJS both on the front end client and on the server to basically handle working with these data types, pulling them out into forms we can understand, like JSON, and then making changes to them and passing those changes over the wire. And I think VueJS is the original, but this comes out of a project that is also managing porting this specific implementation of CRDTs to a number of other languages. So there's a C# implementation. I think there's probably Python and certainly Rust and other implementations of this specific kind of CRDT that Y provides. So a big round of thanks for them. And this is the link I was alluding to earlier. If you are interested in CRDTs and how they work, this is a really, really awesome blog post with a ton of interactive or like animations that kind of describe how the parts work and how it actually figures out how to coordinate these various changes, which can come in, sometimes they'll come in one order, sometimes they'll come in another order, but we have to be guaranteed that whatever comes out the other side is always going to be the same. So highly recommend checking this blog post out.
Yeah.
So if we go back to our diagram, I think the last big part of the ecosystem, which Tim and you asked about, that I haven't talked too much about yet, is the functions themselves. So we talked about the infrastructure that holds and runs them, which is the AWS Lambda service. And we talked about the CLI, which is basically like how you create one yourself on your computer. But what actually is a function? Functions are a piece of code that is responsible for creating a building system, and how you define a building system is sort of up to you. We can talk about an entire structural system. We could talk about a system that only encompasses, a certain set of beams or columns. There are lots of different ways to define the boundaries of what constitutes a system. That's sort of up to you. And each of these functions basically defines what its inputs are, what information does it need from the user, or what options or parameters are there. What other parts of the model does it need access to? So the structure function probably needs to know where the levels are and what the building is shaped like. And it produces outputs, and these can be BIM entities like beams and columns, as well as data-oriented outputs like, numerical values or tables or other things like this. So every function on Hypar basically does this. It defines its inputs, it defines its dependencies, it executes a little bit of code that is the logic of the system itself, and then that gets passed out in the form of whatever outputs it wants to produce, which can be both geometric and non-geometric. And we compose these into a workflow. So when you're building a Hypar project, as I said before, we call that a workflow. It is just a collection of these functions and the inputs that you've set on those functions. And, in that earlier animation, I was talking about how this allows you to kind of swap out logic and have everything still work together. So it's not dissimilar from, a graph on Dynamo or Grasshopper, except that the pieces are entire building systems instead of like add, subtract, move, and that they wire themselves together. So when I pull in a new envelope function, because it knows what it makes and it knows what it needs, we can automatically wire it all together with all of the other systems in this workflow. And in order for this to work, these systems have to speak a common language. So they have to have a common understanding of what kinds of things there are in the world, and they have to be able to read the geometry produced by one in another function. So that's where what we call elements comes in. So elements is our kind of core geometry and BIM library for Hypar. And it defines the types of elements that there are and builds them up out of data and geometric primitives. So in addition to being able to sort of describe a thing, like what is a column? What properties does it have? What does it look like? We also have a bunch of geometry tools that allow you to do things like raycasting and offsets and intersections and draw polylines and do extrusions and do Boolean unions and things like that. So it is both a geometry library and a kind of schema for representing object types. So when I say schema, all I really mean is it is a way to specify what properties constitute some particular common type that we want to share between systems. So one of the coolest things about Elements is that it is open source. It is on GitHub, and you can use it, you can contribute to it, and you don't even need to use Hypar to take advantage of it. We have a lot of folks who use Hypar just like as a library in a Revit add-in that they want to ship, or in some standalone application that they want to build. You can use it in Rhino, you can use it in Revit, you can use it to make a console app, you can use it to basically anywhere that you would want to use C#. And I think this is actually one of the most underrated pieces of Hypar's ecosystem. It is, it's a labor of love. Ian, our founder, really started building this up from scratch. And it has really grown into a pretty functional and capable library for working with geometry and BIM data.
So I see element serialization IFC. So that'll take any part of the schema and IFCify it?
Yep, we have, so one of the things that comes sort of for free if you work with Elements is that we already have a really flexible translation layer between Elements and other formats. So you can get 2D CAD via DXF, you can get IFC out, you can just get a bare JSON representation, you can, and then we have, we have integrations with Revit that allow you to read in that representation and generate native Revit content. You can import that JSON into Rhino and generate native Rhino models. And, if you start building against Elements, then you get all of that stuff for free. And, I think that it's a pretty powerful prospect. Now, you'll notice that I've mostly focused on desktop applications, and we'll come back to how we take advantage of this on the web in a little bit. But I want to dwell for a minute on the idea of schemas, because I think it's sort of an important concept. The sort of founding principles of Elements, and you can read this on the GitHub, are that it has to be small and fast. It has to run in these microservices like our Amazon Lambdas, but it'll run in any Linux service that you want it to. It's got to have visual documentation. It can't have any dependencies on proprietary geometry kernels or applications. So it's got to be MIT licensed and free to use. And, like we just talked about, it has to be able to speak to formats that are useful to engineers and contractors and architects like IFC. And, I think one of the other really important points here, it's kind of buried in this list, is that serialization and deserialization of types that extend element should be possible, provided that those types are made up of primitives defined in this library. So what the heck does that mean? That is actually a critical point. It means that any user of Elements or any user of Hypar can define their own first-class types and not have to modify the elements library itself. So you can define your own schema, your own way of structuring data, and it plays naturally with elements. So if you've already got a JSON structure that you want to use, it'll work fine with elements. If you just want to define, you want to talk about beams or walls or columns differently than we do because you've got some special construction system, you can define your own types that represent that system, and they will play with all of the other types in the elements ecosystem, no problem. Functions will be able to consume them. You'll be able to set up how they convert to IFC and DXF and all these other formats. So, I think this is it's a pretty powerful tool at your disposal, whether you're doing desktop development or starting to build out microservices like we are. And there's a new development that I'm really excited about, which allows us to actually take advantage of elements on the web directly. Before I jump into that, though, I see John has some questions.
Yeah, I was trying to paraphrase it. Maybe you can just read it and.
Yeah, so John wants to know, is it worth treating elements like a kind of reference archive format for geometries on the basis that the output converter tooling is getting good enough to enable universal outputs? Or is this likely to generate artifacts and low quality output that's only useful for emergency conversion? So it's a great question. Universal formats are hard. There is no single format that is going to encompass all of the meaningful information in every platform that it might want to communicate back and forth with. I think the most credible take on this coming out now are things like either NVIDIA Omniverse or the Pixar, what's that format called? They have
yeah, I
can't
pull it up.
think of it. Someone in the chat will think of it. But there are attempts to basically make this sort of universal format. But I think insofar as you can basically use any
USD.
arbitrary object
the
schema,
USD, I looked it up
thank
for you.
you.
Yep.
Yes, that's the one. Insofar as you can use any arbitrary object schema and it's basically just human readable text, it is not a bad choice as an archival format. That doesn't mean that there won't be a lift in having it work seamlessly or translate to other file formats. I guess actually the other one we should mention is IFC. IFC is attempting to be this file format for AEC, but I think we won't go deep down the IFC path in this conversation. But there are lots. But
I do think your point about the universal is complex, and so I think the question about universal, formats are good for what they're designed for. And they can be designed for a large variety of uses and in many, many ways. And we can try to think about the ways that it will be used. But at some point, there's an outer edge to the uses that you can think of. And so the universal is constrained to that and whatever else it adjacently works for. And that can be abstracted into something very universal, but that's the reality. And that's why we see things taking smaller spaces, like 3JS format, does what it does, obviously data schemas and things like that. We are getting a few more questions. I also want to just do a quick time check here. I am going to cut this off at an hour just for our reality, but I do think that this kind of interaction is almost just as valuable as any parts of the things that Andrew has prepared for us. So please keep throwing questions out in there. If you don't get your questions in the next 10 minutes, we may not get to them at the end. So I'll just kind of prime people as they're thinking about the kinds of questions. And we may not hit every question in the chat, and we can take those into the comments below the conversation. But thanks for throwing those out there. Yeah.
So should I keep going or?
Yeah, let's keep going, and I'll look at these questions as they come up. Yep.
Cool. So actually, this is I saw the question about what's the next big focus for Hyper. We're gonna look at a couple of those. So one of the things which is really exciting, a sort of technical development which we are benefiting from, is that there's a lot of tooling emerging around WebAssembly. This is a new standard for executing code in the browser. So the classic way you execute code in the browser is you use JavaScript, period. That's all you got. WebAssembly is a way to write code in many different languages. It is a common compile target for these various languages, and it can run in the browser, on a mobile device, on a desktop, on a server. And you cannot yet compile C# directly to WebAssembly, but they have compiled what's called the .NET runtime to WebAssembly, which means that you can actually execute C# code in the browser. And so that's something we're really excited about. It has enabled us to do things like this. So this is not yet released, but this is a way to, in HyperR, write code and interactively compile it. So if I make this a 7-pointed star, it will actually recompile this C# code and regenerate the geometry on the fly. I can set up what I want my inputs to be. And actually, let's build out something a little bit more exciting here. So I'm just going to copy and paste in the interest of time. If I wanted to create like a spinning arrangement of these, and let's make each one like a height of 1, you can see I'm just like editing the code on the fly. And this is compiling that C# code in your browser. Chrome is compiling this. You can run it on your phone, and it will compile your C# code. So it's pretty interesting as a technology. We're really excited about it, and we hope that it just makes elements more and more relevant in more and more contexts. One more example I'll just dump in here real quick that I cooked up in advance. Since we're talking about the building blocks of HyperR, I thought it was only relevant to do some Lego stacks. So I made a little elements code here, which creates some Lego bricks, using elements as the library and using HyperR as the kind of authoring environment, this sort of scripting world. And we anticipate that this will become eventually the sort of primary way by which functions are created. So you don't even have to download the CLI. You don't have to download an IDE. You can just start putting the logic of your system directly into HyperR and then publish it and make it available for other people to use as functions. We're not quite
I don't know
there
if you
yet.
could see this on your screen, but it's beautiful that a Lego's been described as a rectangle with 6 circles. I think it was 6 circles on top. I'm trying to like look on my screen really, really small, but I think that's beautiful. I do have a question about the compiling and kind of pairing off something coming up here in the chat, and then also with what you've talked about previously. So I'm going to sound really naive, but I'm going to take my best stab here. You're compiling the C# here. It's then going into a Lambda function on AWS and becoming a component that can be used, or that AWS Lambda compilation is separate from what you're showing? Again,
so
I realize this
a
might
great
show
question.
my naivety.
No, it is not doing that. So the thing that makes this different from the other way that code is executed on HyperR is that this is happening in your browser. Your code is actually not leaving your browser. It is getting compiled by Chrome, which is utilizing WebAssembly to execute C# in using the .NET runtime compiled to WebAssembly.
Yeah, and then the question is about performance and speed. Can you speak to that for kind of more or less complex? Like, where's the limitation of this kind of C#?
Yeah, I mean, larger, the thing that I notice, and
I mean, hopefully nobody's writing like a full program, in their web browser live, or maybe that's the intent.
The thing that happens is that as things get more sophisticated, because it's happening locally, it starts to bog down your
memory,
your browser. It's taking more memory, it's doing other things. So it's always a design trade-off. How much do you want to happen on the client, and how much do you want to happen on a server where someone else's compute problem and all you have to do is display and interact with it? So I don't know which things in HyperR's world are going to take what pathway, but I think the thing that's really exciting is that we have both of those pathways open to us. We can build code that executes in the client. We can execute that same code on the server. We can make intelligent decisions on the fly. Like maybe if it looks like this code is going to take a really long time to run, we put it on the server and then we wait for it. And if it's just, live preview of some quick little geometry edit, it can happen locally. We have a ton of flexibility around tuning performance to the environment that it's most suited for. So the big answer is basically we don't know yet.
No, sure. Thanks. And we can kind of keep going, but thanks for for taking a few of these questions. Again, keep posting those questions. There's one about MEP use of HyperR. I'm going to leave that towards the end, but we can kind of keep going.
Yeah, I'd love to come back to that.
Mm-hmm.
So the one last thing that I want to show is that because HyperR functions are written in C#, they are little isolated lambdas. That means you can rely on other C# libraries like the OpenAI API. So you might have seen this was just on the cover of AEC magazine. We've been starting to experiment, just like everybody, with integrating AI into our apps. This is an example of basically like utilizing a prompt to drive the generation of building geometry on HyperR. So I wrote, a 4-story residential building, and it's generating a 4-story residential building. If I say a 3-story garage podium with a 4-story residential tower on top, it will regenerate based on that. And there's nothing magic here. All this is calling GPT via the OpenAI API to basically turn this natural language prompt into parameters that all of the other stuff on HyperR can build. So unlike something like Midjourney, where it's taking your prompt and fuzzing every possible solution in the entire world until something crystallizes, all we're getting out of this are parameters, but we can use this as a new interaction mode for the kind of existing automation capabilities on HyperR. So, as I start editing this, all I'm doing is really setting the input, setting the options on the various functions in the HyperR ecosystem. And the cool thing is that, because we're doing it that way, we've got full BIM out the other side. It's not just like a fancy graphic of something that when you squint at it has 7 fingers. Like, it's real interactive BIM. You can select objects, you can move them around, you can schedule them and quantify them and do whatever you would with, a real detailed 3D model. And it's all being generated from a prompt. I mean, I say it's all being generated from a prompt and a ton of really sophisticated parametric models, which are really the kind of lifeblood of HyperR as a system. And one last slide, and then we can reserve the remainder of the time for questions. The other place where, and I talked about Copilot earlier, but where these AI models really shine is in generating code from a prompt. And so this is another experiment kind of along these similar lines. And this is actually, I should say, this is just a HyperR function. What you're seeing here, I just wrote a HyperR function to take in a prompt and generate source code and then compile and execute that source code within the logic of the function. And so, you can imagine, though, that you could start describing the logic of a building system using natural language and not have to write the code yourself. You can here too. You can also edit the code directly if the AI makes a mistake or you need to tweak something or you're just using it as a learning tool. But I really feel like this is the direction which is going to be, kind of like the successor to Grasshopper in terms of making architectural coding accessible to a wider audience. All of a sudden, it's going to be possible to just write natural language and describe the logic of a building system or a building component. It won't work super well right out the gate. Like, ChatGPT doesn't know a ton about geometry and things like that. I really had to
HyperR.
Yeah, it doesn't know much about HyperR, but you can see where all of this stuff is going. And I'm really excited for the revolution where more people can participate in basically like describing the logic of systems instead of modeling individual elements by utilizing tools like AI and code generation to turn their ideas and design concepts and rules into executable code.
Yeah. Well, we've got 5 minutes, so I want to dive into a couple pieces here. First of all, thank you, Andrew. Huge thank you to you for this. And I think one of the questions that comes up for me, well, actually, I think a thing I want to point out with what you've shared. So this entire series is about connecting computational designers with the web. And the big question comes, why? Like, why? It doesn't really matter. Everything's inside my network. Everything's right here. I open this software or that software, and why do I need to connect to the web? And some of you are looking and going, oh my goodness, yeah, Tim, man, that's not even a question. Like, we don't even need to answer that question. But the reality is there's some people and some of you here who are watching that are wondering that exact thing. And I want to point out that, first of all, someone else recently pointed out that an API does not have to be a web API, right? There's lots of APIs that allow people to connect other things with what you're working on and not being web connected. But I think we're seeing more and more things moving into the web, and it becomes really interesting when all of a sudden something like ChatGPT and OpenAI becomes available. And what you just showed, and I think the second one, did you say the second one was Copilot, or the second one was also
They're all
GPT?
GPT.
They're all GPT. So now you're able to just kind of connect with this web API because you have a framework that's set up to do that, and because you've been thinking about that all along. And we all need to be doing that. We need to be thinking about our tools and how they can be extended with stuff we're not having to create and fully maintain, right? We don't need to maintain how our words become ones and zeros. So let's free ourselves from needing to maintain every way that geometry is creating and using libraries like 3DM or using Hypar's object model that he's been showing. And I think that's where having things that are web connected kind of frees us up to go. So with that, I'm still looking at the chat here for a few questions. I mean, there was one around MEP, and I want to hit that.
Oh yeah.
And just like examples of how Hypar, people use Hypar.
Yeah,
For that.
let me see if I can pull up a good MEP example here in the background.
And I think some examples I know of like environmental studies and the data that's out there. Like again, thinking about connecting with a larger ecosystem, like there's a lot out there that allows that designers can connect with when they are thinking in a web connected sort of way. Thank you everyone for tuning in, for watching this live or watching afterwards. Put comments down in the below. Andrew is one of those people who's diligent to keep track of those things.